Welcome to this second video as part of Unit 7, where we delve into the exciting world of solar energy in agriculture. This unit will explore how solar energy solutions can transform farming practices and contribute to a greener future. Our primary learning objectives for this section are to develop a comprehensive understanding of solar energy systems in agricultural settings, to identify their key applications on farms, and to critically evaluate both the benefits and the limitations of solar power in modern farming practices. As we embark on this exploration, we will uncover the transformative potential of solar energy, a clean, abundant, and increasingly accessible resource, and how it is revolutionizing the way agriculture operates worldwide. From powering essential farm equipment to enabling off-grid operations, solar technologies are rapidly becoming indispensable tools for enhancing sustainability, efficiency, and resilience in the agricultural sector. Solar energy is rapidly emerging as a cornerstone of modern sustainable agriculture. Its virtually unlimited availability ensures that farms, regardless of their size or location, can harness the power of the sun to meet their growing energy demands. As installation costs continue to drop and solar technologies become more efficient and accessible, an increasing number of farmers worldwide are turning to solar solutions to power everything from irrigation systems and water heating to processing operations and cold storage. What truly distinguishes solar energy in agriculture is its remarkable flexibility. The modular nature of solar panels and related equipment allows for easy customization and expansion. This makes solar power particularly well suited to the diverse and dynamic needs of farms. Whether a smallholder farmer in a remote rural area or a large-scale commercial agricultural enterprise. Moreover, solar energy supports not only the economic viability of farming operations by reducing energy costs but also contributes significantly to environmental sustainability by lowering greenhouse gas emissions and decreasing reliance on fossil fuels. By integrating solar power, agriculture takes a significant step forward toward a cleaner, more resilient, and more productive future. Starting with photovoltaic systems, these are undoubtedly among the most widely used and impactful solar technologies on farms worldwide. At their core, photovoltaic, or PV, systems consist of solar panels that capture sunlight and convert it directly into electrical energy through the photovoltaic effect. This clean electricity can then be used immediately or stored for later use. One of the key advantages of PV systems is their flexibility in installation. Panels can be mounted on rooftops, placed on unused or marginal land, or even integrated into farm structures such as greenhouses. This allows farmers to make optimal use of available space without disrupting agricultural activities. Photovoltaic systems power a diverse array of farm operations. They can supply electricity for lighting barns and pathways, operate water pumps for irrigation, and run various types of farm machinery and processing equipment. Their ability to function in both on-grid and off-grid configurations means they are equally effective in well-connected farms and in remote, off-grid locations where conventional electricity access is limited or non-existent. Furthermore, the modular nature of PV systems allows farms to start with small installations and expand capacity as needed, aligning energy production with growing operational demands. This scalability is particularly beneficial for small and medium-sized farms seeking cost-effective and sustainable energy solutions. By integrating photovoltaic systems, farms not only reduce their dependence on fossil fuels but also enhance their overall energy resilience and economic viability, making solar power a truly transformative tool in modern agriculture. Photovoltaic systems are not just efficient, they are also highly adaptable to the specific energy needs of farms. By converting sunlight directly into electricity through solar panels, they offer farmers a clean, renewable power source that can be applied to a wide variety of agricultural operations. One of the most critical applications is in irrigation and water pumping. Solar-powered pumps provide a dependable water supply, especially in off-grid or remote areas where traditional energy access is limited. This allows for greater control over watering schedules, even during dry seasons or peak demand times. Photovoltaic systems are also used for electric fencing and security lighting, helping to protect farm boundaries, livestock, and valuable equipment. With solar-powered lights and perimeter fencing systems, farmers can ensure constant protection, day and night, without relying on grid electricity. Another essential application is in cold storage and refrigeration. By using solar power to run cooling systems, farms can preserve perishable goods immediately after harvest, dramatically reducing spoilage and post-harvest losses. This is particularly important for fruit, vegetable, and dairy producers. Moreover, PV systems can power on-farm processing units, such as machinery for cleaning, milling, drying, or packaging agricultural products. This not only improves efficiency but also adds value to farm output by enabling post-harvest handling directly on site. Whether it's improving productivity, supporting food preservation, or enhancing farm security, photovoltaic systems provide reliable energy where and when it's needed most. One of the biggest advantages of solar PV systems is their very low operating cost. Once installed, they need little maintenance and no fuel, helping farmers save money over time, especially in areas where fuel or grid electricity is expensive or unreliable. PV systems are also highly scalable. A small panel can power a fence or water pump, while larger arrays can run irrigation systems or cold storage units. Farmers can start small and expand as their energy needs grow. And perhaps most importantly, solar PV gives farmers true energy independence. It replaces noisy, polluting diesel generators and reduces dependence on unstable grid power, cutting emissions while making farms more resilient and sustainable. Beyond photovoltaic systems, another important category of solar technology used in agriculture is the solar thermal system. Unlike PV systems, which convert sunlight directly into electricity, solar thermal systems are designed to capture and utilize the sun's heat energy. These systems typically consist of solar collectors, insulated storage tanks, and heat exchangers, working together to absorb solar radiation and convert it into usable thermal energy. This thermal energy can then be applied to a wide range of farming processes, from heating water for livestock and sanitation, to supporting drying systems for grains, fruits, or herbs, and even assisting in greenhouse climate control. Solar thermal systems provide a reliable and cost-effective alternative to electric or fuel-based heating, especially in areas with strong, consistent sunlight. Their design is relatively simple, which allows for easy integration into existing farm infrastructure, while also reducing dependency on more complex and expensive electrical systems. While they may not replace electricity-based technologies in every case, solar thermal systems fill a crucial role in farming operations that require direct, sustainable heat, offering both energy efficiency and environmental benefits in the process. In agriculture, solar thermal energy provides a practical and efficient way to supply heat for daily operations. One of its most common uses is water heating, for livestock hygiene, equipment cleaning, or food processing, offering a clean and low-cost alternative to electricity or gas. It's also used for crop drying, where solar-powered drying chambers help preserve grains, fruits, and herbs with better quality and hygiene, reducing spoilage and energy costs. In greenhouses, solar thermal systems help maintain stable temperatures during cold periods, supporting healthy plant growth and lowering fuel consumption. They can even regulate water temperature in aquaculture, ensuring ideal conditions for fish or shrimp farming. Overall, solar thermal systems help farms cut costs, reduce emissions, and gain greater energy independence, paving the way toward a more resilient and sustainable agricultural future. In modern farming, solar thermal systems provide practical and reliable heat for everyday operations. Hot water is one of the most important needs, used for cleaning equipment, maintaining livestock hygiene, or processing products like milk and cheese. With solar heating, farms can meet this demand cleanly and at low cost. Using free energy from the sun. Solar heat is also valuable for crop drying, helping preserve grains, fruits, and herbs in a controlled environment that improves quality and reduces spoilage. In greenhouses, it helps maintain stable temperatures during cold periods, promoting healthy plant growth while cutting fuel use and emissions. From water heating to drying and climate control, solar thermal systems give farmers a sustainable way to manage energy, reducing costs, lowering their carbon footprint, and building greater self-sufficiency. As solar technologies advance, agriculture is turning towards smarter and more integrated energy solutions. One of the most promising innovations is the hybrid solar system, a setup that combines photovoltaic and thermal technologies to produce both electricity and heat from the same installation. These PVT systems allow farms to power equipment and lighting while also supplying hot water for cleaning or crop drying. By using one surface for dual energy output, they save space, boost overall efficiency, and improve reliability under different weather conditions. Hybrid solar systems represent the next step in sustainable farming, helping producers reduce costs, lower emissions, and make better use of every ray of sunlight. At the heart of a PVT system are photovoltaic cells that generate electricity from sunlight. Just beneath them, a thermal collector captures the heat that would otherwise be lost and repurposes it for on-farm uses like water heating or crop drying. By drawing away excess heat, the system keeps the solar panels cooler, which helps maintain their electrical efficiency. This way, both forms of energy, electrical and thermal, are produced together, maximizing the output from each square meter of solar panels. For agriculture, that means one compact system delivering both power and heat efficiently, sustainably, and at lower cost. Private systems are ideal for farms that need both electricity and heat. They make it possible to use the same solar installation for multiple agricultural purposes. In greenhouses, they provide power for lighting and ventilation, while also supplying heat to maintain the right temperature for year-round production. In livestock farms, they can deliver hot water for cleaning and disinfection, and electricity for lighting, fans, and feeding systems, all from one setup. For food processing and storage, private systems supply both the heat needed for drying or pasteurizing and the electricity for machinery and cooling. They can even support irrigation and water pumping. In colder regions, they help keep water warm enough to prevent freezing or shock to animals. And after harvest, the thermal energy from private systems can be used for crop drying, reducing moisture content in grains, fruits, or herbs without burning fuel. Overall, private systems make farms more efficient, sustainable, and less dependent on external energy sources. When we talk about sustainable farming and energy efficiency, private systems stand out as one of the most powerful and practical technologies available today. They bring together the best of both worlds, producing clean electricity like photovoltaic panels, while also capturing the sun's heat for direct thermal use. This dual output makes them especially beneficial for farms, where both energy forms are constantly in demand. Let's take a closer look at the key benefits of private systems in agriculture. Enhanced energy yield and efficiency. Unlike conventional photovoltaic panels, which only convert sunlight into electricity, private systems utilize the full solar spectrum. They can reach overall efficiencies of up to 70 to 85%, combining around 15 to 20% electrical efficiency with another 50 to 65% in thermal energy. That means every square meter of private surface produces far more usable energy than a standard PV panel. This is a major advantage in farms where roof or ground space is limited, such as greenhouses or compact livestock facilities. Energy autonomy and cost savings. By generating both electricity and heat on-site, farms become more energy independent. They reduce their reliance on external suppliers, protect themselves from fluctuating fuel prices, and gain greater control over their operational costs. This kind of hybrid energy production not only saves money but also provides stability in areas where the power grid is unreliable or expensive to connect. Over time, the savings from reduced energy purchases and increased efficiency can cover the investment costs and provide long-term financial benefits. Better land use efficiency. Land is one of the most valuable assets in agriculture. Traditional energy systems often compete with crops or facilities for space. Private systems solve this issue by combining functions in a single installation. Instead of having separate panels for electricity and separate collectors for heat, one system provides both. This allows farmers to maximize land productivity and preserve valuable cultivation areas, an especially important advantage in high-value or intensively farmed regions. Sustainability and carbon reduction. Replacing diesel generators, gas burners, or grid electricity with clean, solar-based private systems dramatically reduces carbon emissions. It helps farms move toward climate neutrality and aligns with international goals for low-emission and renewable-based agriculture. Beyond reducing the carbon footprint, it also improves the environmental image of the farm, something increasingly important for markets, certifications, and eco-conscious consumers. System synergy and longevity. Another major advantage of private systems lies in their built-in synergy. The thermal component doesn't just collect heat, it also helps cool down the photovoltaic cells. Lower cell temperatures mean higher electrical efficiency and a longer lifespan for the panels. So, while the system captures usable heat for farm processes, it simultaneously enhances the performance and durability of the PV side. This interconnection makes private a truly intelligent and balanced energy solution. In summary, private systems provide a complete, efficient, and sustainable energy package for modern agriculture. They save space, cut costs, improve energy reliability, and reduce emissions, all while supporting a cleaner, more resilient future for farming. Agrivoltaics, also known as dual-use solar, is an innovative approach that combines solar power generation with agriculture on the same land. In this system, crops or animals share space with solar panels, allowing both food and energy production to occur simultaneously. This greatly improves land use efficiency and supports more sustainable farming practices. The concept was first proposed by Adolf Goetzberger and Armin Zastrow back in 1981. But it's only in the last decade that agrivoltaics have started to gain real momentum worldwide. While the shade from the panels slightly reduces the amount of sunlight that reaches the crops, this isn't always a disadvantage. For certain plants, reduced heat and evaporation can actually improve yields, and, of course, the generation of renewable electricity compensates for any loss in crop production. Typically, solar panels are mounted several meters above the fields, allowing tractors and other farm machinery to move freely below. They can also be installed on greenhouse roofs, maximizing space even further. A more flexible design, called dynamic agrivoltaics, uses lighter panels suspended on cables that can be tilted or moved depending on the season and crop type. Modern systems even include sensors and smart software that monitor plant growth, sunlight, and weather, automatically adjusting the position of panels to balance crop health and energy output. In the future, new semi-transparent solar materials will allow more light to pass through for photosynthesis while capturing the remaining wavelengths for electricity generation. Agrivoltaics represent a new vision of agriculture, one where clean energy and food production coexist in harmony on the same land. Agrivoltaic systems bring powerful benefits to modern farming. They allow food and energy production to exist side by side, on the same land, creating a truly sustainable model for agriculture. By combining solar panels with crops or animals, farmers can make better use of their land. The same field now produces electricity and food at the same time. Nothing is wasted. The panels also help protect crops. Their shade softens the sunlight, shields plants from extreme heat, hail, and drought, and keeps soil moisture from evaporating too quickly. In hot or dry regions, This cooler microclimate can actually improve plant growth and reduce stress on crops. For farmers, agrivoltaics mean more than sustainability. They mean opportunity. Electricity produced on-site can power irrigation systems, lighting, and equipment. Or it can be sold back to the grid, creating a valuable new source of income. It's a steady way to lower costs and boost farm profits year after year. Another major benefit is improved water efficiency. The shading from solar panels helps the soil retain more moisture. Less evaporation means less irrigation, saving both water and energy. This is especially important in arid regions, where water is precious and every drop counts. Agrivoltaic systems prove that farming and renewable energy can work together, not in competition but in harmony, growing food, generating power, and building a more sustainable future for all. Solar-powered water pumping is one of the most practical and impactful uses of solar energy in agriculture. It offers farmers a reliable, clean, and cost-effective way to move water, even in remote areas where electricity grids are weak or diesel fuel is expensive. In simple terms, a solar water pumping system converts sunlight into electricity to power an electric pump. That pump draws water from a well, a river, or a reservoir, and delivers it where it's needed, for irrigation, livestock, or household use. The system is built around two main components. First, the solar PV array. A set of panels that capture sunlight and convert it into electrical energy. Second, the pump set, which uses that energy to lift and transport water. Depending on the setup, the pump can operate on direct current, known as DC, or alternating current, known as AC. The PV array connects directly to the pump, or sometimes through a controller that regulates power flow. When sunlight hits the panels, they generate a steady DC current. This current drives the pump motor, enabling it to extract and move water efficiently, without the need for fuel or a grid connection. The beauty of solar water pumping lies in its simplicity and sustainability. It provides water whenever the sun shines, matching natural irrigation needs with daily solar cycles. For farmers, this means dependable access to water, lower operational costs, and zero emissions. Solar water pumps are helping transform agriculture in sunny regions around the world, making it cleaner, more resilient, and more self-sufficient. Solar water pumps are transforming modern agriculture by providing clean, reliable, and affordable access to water, powered entirely by sunlight. They eliminate the need for expensive grid electricity or diesel fuel, helping farmers reduce their operational costs and gain true energy independence. In remote or rural areas, where power supply is often unreliable or unavailable, solar pumps ensure a steady and dependable source of water for irrigation and livestock. Unlike traditional diesel pumps, solar-powered systems have very few moving parts. They require minimal maintenance, experience fewer breakdowns, and can operate efficiently for many years with little technical attention. No oil changes, no refueling, no noise, just smooth and silent performance. Beyond practicality, solar water pumps are also environmentally friendly. They produce no greenhouse gases, no air or noise pollution, and rely solely on clean renewable energy. This makes them a key solution for sustainable agriculture and for reducing the environmental footprint of farming. Solar pumps also make it possible to access water in remote areas that lack electricity infrastructure. They can operate almost anywhere the sun shines, opening up new opportunities for cultivation and livestock management in previously underdeveloped regions. And finally, government programs and subsidies, such as the MNRE capital subsidy, help make these systems more affordable for farmers, reducing the initial investment cost and encouraging broader adoption. By lowering costs, improving reliability, and protecting the environment, solar water pumps empower farmers to work more efficiently and sustainably, using the power of the sun to secure the water that sustains life and agriculture. Standalone solar lighting and fence systems are a smart and efficient way to bring clean energy to farms and rural properties. These systems operate completely independently, without any connection to the electrical grid. Relying only on the power of the sun, they are especially valuable in agricultural environments where lighting, fencing, and security are essential. But extending grid power is costly or impractical. By converting sunlight into electricity, these standalone systems ensure reliable operation day and night, with minimal maintenance and zero fuel costs. Solar lighting systems work by using photovoltaic panels to capture solar energy during the day. That energy is stored in batteries, which then power lamps or floodlights at night. This provides consistent illumination for pathways, barns, storage areas, or animal enclosures, improving safety, productivity, and visibility after sunset. Similarly, solar fence systems use solar power to energize electric fences. The solar panels charge a small battery that supplies power to the fence controller, creating a steady and safe electrical pulse. This helps keep livestock secure and protects crops from wild animals, even in locations far from any power infrastructure. Together, standalone solar lighting and fencing systems offer an affordable, reliable, and environmentally friendly solution for modern agriculture. They increase safety, reduce operational costs, and give farmers full independence from the electrical grid, all while using clean, renewable energy from the sun. Standalone solar lighting and fence systems bring a range of practical and sustainable benefits to modern farms and rural areas. They provide reliable power for essential operations, lighting, safety, and security, without depending on external electricity networks. One of the main advantages is cost savings. Because these systems operate entirely on solar power, there's no need to connect to the electrical grid or pay monthly electricity bills. Over time, this leads to significant reductions in operating costs, especially for farms spread across large or remote areas. Another key benefit is energy independence and reliability. In rural or isolated regions, the electrical grid can often be weak, inconsistent, or completely unavailable. Standalone solar systems remove that uncertainty, providing steady, reliable power wherever it's needed, day after day. They are also environmentally friendly. Running completely on renewable solar energy, these systems produce no greenhouse gas emissions and no pollution. They help reduce a farm's carbon footprint and support cleaner, more sustainable agricultural practices. And finally, low maintenance is another major advantage. With few moving parts and robust designs, solar lighting and fence systems require minimal upkeep and have long lifespans. Once installed, they can operate efficiently for years with little more than routine cleaning of the panels. Overall, standalone solar lighting and fence systems offer an affordable, durable, and eco-friendly solution for powering rural operations, helping farmers save money, improve safety, and move toward a more sustainable future. In conclusion, solar energy has proven to be one of the most practical and scalable solutions for modern agriculture. It can power irrigation systems, support crop drying, and provide reliable lighting, all while reducing costs and protecting the environment. With the right support programs and incentives, more farmers can adopt these technologies and become energy self-sufficient. Step by step, solar power is helping agriculture move toward a cleaner, smarter, and more sustainable future. The sun, after all, has always been the source of life for farming, and now, it's becoming the source of power as well. Thank you for watching and learning about the role of solar energy in modern agriculture. The more we understand, the better we can farm, and the brighter our shared future will be.